second example is y equals 3 times 4 to the x power, an example of exponential growth or decay. And then what is the y-intercept? Well, first of all, to figure out if we have growth or decay here, I want to look at this b value. Okay. Use another colored underline. When you look at my b value, which is more than 1. So that tells me I have exponential growth. And then our y-intercept is our a value, which is 3. Now, something else to kind of keep in mind and to remember, if I look visually for a second at a graph, keep in mind that the y-intercept happens when your x value is 0. So if you needed to, if you weren't sure, like, hey, which one is the y-intercept, which one is the growth rate, we could also try plugging 0 into your equation, and that will tell you what your y-intercept is, if you ever, needed to verify something. So again, I could find my y-intercept by plugging 0 into my equation. 4 to the 0 power is 1 times 3 is 3. Now, one more situation quick here. A similar equation. Let's look at the equation y equals 2 times 3 to the negative x power. Same questions. Is this exponential growth or decay? And then what's the y-intercept? Well, one thing we have to be careful with here is this does not match up with our general form for exponential functions, because this isn't in the form a times b to the x, since I have this negative x power. So what I really want to do is think of this 3 as 3 to the negative first power, and then to the x, because keep in mind, if you have a power to a power, we multiply these exponents. Negative 1 times x is the negative x that was here originally. Okay. So I haven't changed anything, just wrote my equation a little differently. And then 3 to the negative first power is 1/3. Okay, so even though it looked originally like this was going to be exponential growth, because this b value was 3, really b is 1/3, making us have exponential decay. Okay, and then my y-intercept here is 2.